you can join more than 2 tables. When you do, you create an output table that has a row from each table that you joined, all concatenated together into one long row. And then you can select some of those columns. Let's say we want to create a table with columns title and star that contains one row per movie from 2023, containing the title of the movie and the name of the first actor in that movie. What do I mean by first actor? The one that's most prominent in the film. For example, John Wick Chapter 4, it's Keanu Reeves. For Mission Impossible, it's Tom Cruise. Now, when you think about building an output table, think about building each of its rows. A row from here needs a title from the titles table. It needs a name of the actor from the names table. So that means we need to join together the titles table in order to figure out what's the title of the movie, and the names table in order to figure out the name of the actor. But how do we match them up? The title goes with the star by making sure that in that movie, that actor was ordering number 1, which all appears in the principals table. The point of the principals table is to tell us which people helped make which movies. So even though the output only has columns from the titles and names tables, we need to join in the principals tables to make sure that the rows are coherent. Select title, name as star. I'd think about those last. Where you want to start is with the joins. We need the titles table, principals table, and names table. You could write this with commas or with the word join. And then we need constraints. The on clause here makes sure that when we take a row from titles and a row from principals, they match. They're about the same film. And that when we take that row from principals and match it with a row from names, those match too. They're about the same person. We don't need a constraint telling us how to match up a row from titles with a row from names, because the way in which we match them up is using the row from principals that tells us which actors are in which movies. Then we can add that it was in the year 2023 and we want ordering number 1, the actor that appeared first in the credits. Now there are lots of ways this could have gone wrong, so let's take a look. Here are my tables. First, let's look at a few rows from each of these so we know what we're working with. Select star from titles, limit 3, from principals, and from names. Now we can see the names of all the columns and all the tables, and we can start to join. Let's select the title and the name, like we said. I'd also like to know the name of the character. From what I get when I join together the titles table, the names table, and the principals table. So it's important to use column names here and table names here. And now it's time to set the join condition. I could pick any column from the titles table to join on, but I need to pick a column that has values that match up with values in the principals table. So that's why we end up with this condition. Now I'm intentionally going to leave out the matching between the nconst value in the principals table and the nconst value in the names table in order to see what happens. So normally I would add that here, and whatever. But instead, I'm going to just leave that the way it is, add a where clause that says the year is 2023. That is the year of the film title. And I'll also make sure that we're talking about ordering number 1 actors. Let's see what we get. It's taking a while because it's building a huge table. The table we built using this query correctly matched up the film with the character. So Ethan Hunt is the main character of Mission Impossible movies. But it did not correctly match up that with the name of the actor, which should have been Tom Cruise. Instead, what we see here is that every person in the names table is being matched up with every movie role combination because we never specified that the nconst values that tell us who we're talking about actually need to match. So if I scroll through this, I just see a bunch of nonsense because I didn't have enough conditions in my on clause to make sure that when I built a row in the join table, it was about a particular movie and a particular person. But all I have to do is and make sure that the principals nconst column has the same value as the names nconst column. And then I add in that part about the year and the ordering, and everything is fixed. And now I can see who played J.R. Robert Oppenheimer or Ethan Hunt or Peter Quill. Okay, this is great. The only things I left out is that I didn't want to show the character name, just the title and the name. And I also wanted to rename the name column to the star because we chose ordering 1 as part of the query. And then we end up with the same query that was in the slides. The last thing I want to show you is that you didn't actually have to write on. Instead, we could have written where, and it would still work. Why? Well, these are just conditions. It's a good idea to put the conditions that match rows up in a join in an on clause, because that helps other people read it. But from SQL's perspective, it doesn't really matter whether you write where or on. You can't have 2 where clauses, but you could just keep saying and you'd get the same result. So all of these conditions could have been part of the where, or they could have been part of the on. But the best practice is to put them in on if they're helping figure out how to match up rows from different tables in a join, and leave the where conditions to be selecting parts of a particular table. Now there's one feature that can shorten the size of your query, which is called a table alias. If 2 tables share a column name, then as we've seen, you have to refer to the table and then a dot, and then the name of the column to pick out which column you're talking about. So we've joined together the titles table and the principals table, and they both have a column called tconst. How do you tell which one's which? Well, you use a dot expression. But those dot expressions can be long, and so sometimes you need an alias, which is an alternate name for a table. So inside of a select statement, this table can be a join separated or comma separated list of table names that can optionally be aliased, and the alias of a table is introduced with as. So here's the same query with aliases. Instead of titles join principals join names, I've written titles as T, principals as P, names as N. They don't have to be 1 letter, but that is awfully convenient, because then instead of writing out principals.tconst, I can just write p.tconst, which is easier to type. Everything else is the same except for the dot expressions are using the aliases for the tables.